Hello children. Let's revise definitions of elastic properties of matter. What is elasticity? A force on a body can change its size or shape. The property of a body, by virtue of which it tends to regain its original size and shape, on removal of applied force, is called elasticity, and the deformation caused is known as elastic deformation. What is plasticity? If you apply force to a lump of putty or mud, they have no tendency to regain their previous shape, and they get permanently deformed. Such substances are called plastic, and this property is called plasticity. What is the cause of elastic force? When a solid is deformed, the atoms or molecules are displaced from their equilibrium positions, causing a change in the interatomic or intermolecular distances. When the deforming force is removed, the interatomic forces tend to drive them back to their original positions. Thus the body regains its original shape and size. The restoring mechanism can be visualized by taking a model of spring ball system, where we can connect each ball to its neighbors by springs. What is stress? When a body is subjected to a deforming force, a restoring force is developed in the body. This restoring force is equal in magnitude but opposite in direction to the applied force. The restoring force per unit area is known as stress. If F is the force applied normal to the cross-section, and A is the area of cross-section, stress will be magnitude of force per unit area. The SI unit of stress is Newton per meter square or Pascal. What are different types of stress? Stress can be differentiated into three types. Tensile and compressive stress are generated when a deforming force tries to elongate or compress an object along its length. Shearing or tangential stress are due to force parallel to the cross-section area. Such forces try to change the shape of the object. Hydraulic stress is generated when an object is submerged in a fluid that presses it from all the directions. A restoring force is generated throughout the body that try to oppose the compression. What is strain? Strain is the effect of stress on an object. It is defined as fractional changes in dimensions of the object. Longitudinal stress is equal to change in length per unit length. Volume strain is change in volume per unit volume. Shearing stress is the angle by which an object has been bent. Strain is a dimensionless quantity. It increases as we increase the applied stress. What is definition of Hooke's law? For small deformations, the stress and strain are proportional to each other. This is known as Hooke's law. We can say that stress is equal to K times strain, where K is the proportionality constant, and is known as modulus of elasticity. Hooke's law is an empirical law and is found to be valid for most materials. However, there are some materials which do not exhibit this linear relationship. Example: elastomers. What is stress-strain curve? From the graph, we can see that in the first region between O to A, the curve is linear. In this region, Hooke's law is obeyed. In the second region from A to B, stress and strain are not proportional. Nevertheless, the body still returns to its original dimension when the load is removed. The point B in the curve is known as yield point or elastic limit, and the corresponding stress is known as yield strength sigma y of the material. When the load is removed, at any point between B and D, the body does not regain its original dimension. In this case, the material is said to have a permanent set or plastic deformation. The point D on the graph is the ultimate tensile strength sigma u of the material. Beyond this point, additional strain is produced even by a reduced applied force and fracture occurs at point E. What is the difference between ductile and brittle materials? If the ultimate strength and fracture points of a material are close, the material is said to be brittle. If they are far apart, the material is said to be ductile. Brittle material breaks easily if the applied stress is more than their ultimate tensile stress. Ductile material keeps stretching or flowing for much longer extent. What is an elastomer? Rubber can be pulled to several times its original length and still returns to its original shape. In stress-strain curve for the elastic tissue of aorta, present in the heart, elastic region is very large, but the material does not obey Hooke's law over most of the region. Secondly, there is no well-defined plastic region. Substances like tissue of aorta, rubber etc., which can be stretched to cause large strains are called elastomers. What is modulus of elasticity? The proportional region within the elastic limit of the stress-strain curve is of great importance for engineering designs. The ratio of stress and strain, called modulus of elasticity, is found to be a characteristic of the material. The three important modulus of elasticity are Young's modulus, Bulk's modulus and modulus of rigidity. What is Young's modulus of elasticity? The ratio of tensile or compressive stress sigma to the longitudinal strain epsilon is defined as Young's modulus and is denoted by the symbol Y. Since strain is a dimensionless quantity, the unit of Young's modulus is the same as that of stress, which is Newton per meter square or Pascal. What is the reason to use steel in structures rather than pure metals? To increase the length of a thin steel wire of 0.1 cm square cross-sectional area by 0.1%, a force of 2000. The force required to produce the same strain in aluminium, brass and copper wires having the same cross-sectional area are 690 N, 900 N and 1100 N respectively. It means that steel is more elastic than copper, brass and aluminium. It is for this reason that steel is preferred in heavy-duty machines and in structural designs. Wood, bone, concrete and glass have rather small Young's moduli. What is shear modulus of elasticity? The ratio of shearing stress to the corresponding shearing strain is called the shear modulus of the material, and is represented by G. It is also called the modulus of rigidity. SI unit of shear modulus is Newton meter or Pascal. It can be seen that shear modulus or modulus of rigidity is generally less than Young's modulus. For most materials G equals Y divided by 3. What is bulk modulus? We have seen that when a body is submerged in a fluid, it undergoes a hydraulic stress equal in magnitude to the hydraulic pressure. This leads to the decrease in the volume of the body, thus producing a strain called volume strain. The ratio of hydraulic stress to the corresponding hydraulic strain is called bulk modulus. It is denoted by symbol B. The value of bulk modulus B is always positive. SI unit of bulk modulus is the same as that of pressure. The reciprocal of the bulk modulus is called compressibility and is denoted by K. What is compressibility? The reciprocal of the bulk modulus is called compressibility and is denoted by K. It is defined as the fractional change in volume per unit increase in pressure. The bulk moduli for solids are much larger than for liquids, which are again much larger than the bulk modulus for gases, air. Gases have large compressibilities, which vary with pressure and temperature. What is Poisson's ratio? When a metal wire is stretched, there is a slight reduction in the cross-section or in the diameter of the wire. The strain perpendicular to the applied force is called lateral strain. Simon Poisson pointed out that within the elastic limit, lateral strain is directly proportional to the longitudinal strain. The ratio of the lateral strain to the longitudinal strain in a stretched wire is called Poisson's ratio. It is a pure number and has no dimensions or units. Its value depends only on the nature of material. What is potential energy of a stretched wire? When a wire is put under a tensile stress, work is done against the interatomic forces. This work is stored in the wire in the form of elastic potential energy. When a wire of length L, and area of cross-section A is subjected to a deforming force F along its length, the length of the wire is elongated by delta L. The potential energy is half times stress into strain into volume of the wire. What is amount of bending of beam under a load? Let us consider the case of a beam loaded at the center and supported near its ends. A bar of length L, breadth B, and depth D when loaded at the center by a load W sags by an amount given by delta equals WL cubed 4BD. What is the difference between breaking stress and breaking tension? Breaking stress is a property of a material. But, when we make wires of that material, each one can have different breaking tensions. Breaking tension depends on the cross-section area of the wire. As stress is ratio of restoring force and area, breaking force or tension is multiplication of breaking stress and area. If Tw double the radius of a wire, the area, as well as breaking tension, increases to 4 times. So what did we learn in this video? We learned all important definition of elastic properties of matter. Thank you, children. Make sure you listen again and again, till you can write down all the definitions on your own. Goodbye.